Alright, so this one, we're given a function that is a complex fraction. Got a smaller fraction within a bigger fraction. So before I even want to think about taking the derivative of this, I'd like to rewrite this so that it's not quite as messy looking. So, nice little algebra trick. One way to deal with this is if you think about all of these as a fraction, and you find the least common denominator. As long as you're willing to multiply all of those by that least common denominator, that is going to be mathematically legal. It will not change the size of this. So what I'd really want to do is I really want to multiply this by x, because timesing by x and dividing by x just cancel out. But then that means I need to multiply this by x, and this by x, and this by x. But notice what happens if you do. You've got 2 times x minus 1 over x squared minus 3x. So it's still not super simple, but at least it's not a complex fraction. Now at least I don't have smaller fractions within a bigger fraction. Now I'm going to think about taking the derivative. Looks like I've got quotient rule, something divided by something, and the quotient rule says take the derivative of the numerator times the denominator, subtract the derivative of the denominator times the numerator. And all of that over the denominator squared. Okay, so I've got some distributing here, some distributing or FOIL here, and then hope that some stuff comes together. So I'm going to distribute the 2. So this becomes this. I got minus. Alright, for this, 2x times 2x would be 4x squared. This times this would be minus 2x, but then this times this would be minus 6x. So negative 2x minus 6x would be minus 8x, and then a plus 3. Still over this. Okay, so now I need to get rid of these parentheses, so I really wanted to subtract the whole thing. So it makes the 4x squared negative, the 8x positive, and the 3 a negative. And now finally I can start to combine some like terms. I've got some x squareds here and here. Looks like there's negative 2 of those total. Got some x's here and here. Looks like there's 2 of those total. And I've got a constant of minus 3. And this all looks good, except I do have a little typo right here. These were x squareds and these were x squareds, so when I combine those like terms, I still get x squareds.